Now we're going to talk about identifying systematic errors. So some types of systematic errors that we can see, as I told you before, is actually how the vessel attitude looks like during your survey. So for example, you've got your rotational errors, you've got your pitch in your x-axis. So it's basically your vessel is looking up and down. And then you've got your roll in your y-axis. So basically your vessel is going to the right and left rotationally. And then you've got your yaw, which is basically the heading of your vessel. And then you've got your translational errors. So before it was rotational, right? Now it's translational, which is basically like you've got a movement in this direction. So you've got your sway in X, so you move right and left. And then you've got your surge to the front and to the back. And then you've got your heave, which is the most important one. So you've got a movement up and down. And normally, the bigger your wave is, the bigger your heave would be. So those are the most important things that you need to know. So how do we actually identify systematic errors? So this is an example of a multibeam echosounder that I took. And you can see already that this is not perfect just yet. There are some errors that are quite visible. For example, in this area, so these green lines are the survey lines, okay? So over the survey lines, you've got some perpendicular data that is actually, that is actually wrong. It's wrong because it's out of the normal range. It's not at the right value if it is compared to the surroundings. And then you've got some in here, you've got some in here probably, and those spots. So we'll just see this one because it's, oops, sorry, this is the clearest. So those are basically the roles. Why is it the roles? Because it's perpendicular to your survey lines. It means that it's moving like that, okay? You can feel how it looks like in the field. And then in here, you also have something that looks like a fan, and this one, and then you can still see the perpendicularity of that. So you've got your roll and you don't know what this is because it's either a yaw because it's changing headings. So you have like that kind of fan, or is it actually a pitch because it's looking up and down? So if you zoom into this, you can actually see over this survey line, you've got a yaw that looks like this, and then you have no heave actually, the heave is actually 0. You've got some pitch actually, that's actually pitch, those are not yaw. And then you've got roll, okay? So you know where those come from. Now you know where those come from, how do you actually calculate the right surface? So the first one is actually to compute the standard deviation map to identify the areas with systematic errors and outliers. So you can see here there are some areas that doesn't make any sense, which are red. So green is basically where your standard deviation is okay. And then yellow is somewhere that is actually, you have a warning in there, but red is totally wrong. So you went back to each of your survey line, just like what we did before, and then you want to choose the best hypothetic depth approximation in each survey line. So you're going to choose which one makes more sense. Of course, you want to reject everything up above in here, maybe, okay? And then afterwards, you can recompute your standard deviation and see how it looks like. Now, you compare it to the original data set, and then you've got, the best value you want, okay? And then now we are going